There is no single fusion splicer for every specialty fiber. Aligning a PANDA fiber is different from handling a 500 micrometer cladding, and different again from working with hollow core or multi-core fiber. That is why FITEL S185 is not one machine. It is a family of 8 specialized models built on the same compact platform. Choosing the right splicer starts with the fiber, its diameter, internal structure, orientation, and the required splice strength and loss. Only then do we decide how the fiber should be observed, positioned, and heated. These 3 layers, imaging, alignment, and heat delivery, are the clearest way to understand the S185 family. The S185HS, short for high strength, is designed for standard fibers with an 80 or 125 micrometer cladding when high accuracy and splice strength are essential. The S185PM, short for polarization maintaining, adds precise rotational alignment for fibers such as PANDA. In these systems, matching the cores is not enough. The polarization axes must also be correctly oriented. The S185LDF, short for large diameter fiber, extends the cladding range to 500 micrometers. Its integrated power supply and compact form make it suitable for production workstations as well as complex fiber laser assemblies. The S185PMLDF combines both capabilities: polarization maintaining fiber and large diameters up to 500 micrometers. It is intended for large PANDA fibers, non-standard geometries, and applications that require controlled rotation. At larger diameters, a new challenge appears. How do we heat the fiber evenly? In the S185ROF and S185PMROF, FITEL uses 3 electrodes. The resulting ring of fire plasma field surrounds the fiber with a wider and more uniform heating zone than a conventional 2-electrode system. The S185ROF handles cladding diameters up to 800 micrometers. The S185PMROF adds precise rotational positioning and is intended, among other applications, for multi-core fibers. The manufacturer lists multi-core fiber designs, abbreviated MCF, from 2 to 19 cores. But with hollow core, photonic-crystal, and other microstructured fibers, a side view does not always reveal the features that must be aligned. The same applies to multi-core fibers with an asymmetric marker. In these cases, the end-face view confirms the correct rotational orientation of both fibers. The S185EDV observes the end faces of both fibers. Composite image technology superimposes the 2 views, allowing the operator to compare channels, cores, and other structural features directly. A conventional side view remains available whenever it is needed. The most advanced model, S185EVROF, short for end-view ring of fire, combines end-view imaging with the 3-electrode ring of fire. It also adds STA2D, sequential asymmetric arc control developed for delicate hollow core structures and small diameters. The splicing range reaches 800 micrometers, while the end-view system operates from 125 to 500 micrometers. In highly demanding assemblies, moving the fibers in X and Y may not be enough. The optional active tilt adjustment system also corrects pitch and yaw, the angular position of both end faces. This is especially important in high-power lasers, low numerical aperture fibers, tapers, and fiber bundles. A TA is available for every S185 model, but it must be specified when a new machine is ordered. According to the manufacturer, it cannot be retrofitted to an existing splicer. Even the best fusion splicer cannot compensate for a badly prepared fiber end face. A complete workstation therefore consists of several stages. First, the coating must be removed without damaging the glass. The fiber must then be cleaved to the correct length and angle. The NorthLab ProCleave family includes solutions for thin fibers, large diameters, and processes that require precise micro-positioning. The next stage is end-face inspection. NorthLab ProView Theta performs interferometric measurement, creates a topographic image, and builds a digital model of the fiber structure. The software can compare both end faces, calculate the optimum rotational orientation, and then send the required adjustment to a compatible PM-type S185 splicer. This is particularly useful for MCF, PCF, air-clad, hexagonal, octagonal, and D-shaped fibers. ProView Theta is available in two ranges: LD for cladding diameters from 125 to 800 micrometers, and XD from 250 to 1200 micrometers. After splicing, the process can include coating restoration in a ProCoater and mechanical verification with a tensile tester. The result is not a collection of separate machines, but a repeatable workflow: preparation, cleaving, inspection, alignment, splicing, recoating, and testing. For standard 80 or 125 micrometer fiber, when splice strength is the priority, start with the S185HS. For PANDA and other PM fibers, choose the S185PM. For large diameters up to 500 micrometers, the corresponding choices are the S185LDF or S185PMLDF. When the diameter grows to 800 micrometers, or when a wide and uniform heating zone is required, move to the S185ROF or S185PMROF. For structures that must be observed from the end face, hollow core, PCF, and complex MCF, the selection moves towards the S185EDV. When end view and ring of fire are required together, the answer is the S185EVROF. The most important question is not which S185 is the best. It is which fiber and which process must the system support. When planning a workstation, define the fiber type, cladding and coating diameters, end face structure, and the required splice loss and strength. With this information, Interlab can select the right S185 model, fiber holders, and equipment for fiber preparation and inspection. Explore the complete family at interlab.pl.